Hi and welcome to the equation of a straight line. Yes, I know, how exciting is this? You're thinking y equals mx plus c, and I'm going to go, no, not really, but just don't rush me. It's really good to see you, by the way. Yes, this is part of the Methods 1 and 2 course, but if you are around the world, don't worry about it. Equation of a straight line is universal. Maths is universal. Doesn't matter what course you are following. It is all very much related. So good to see you. Now, if you are new, do me a favor, red arrow over there. If you could click that and subscribe, it just shows me that you're watching and it makes it sort of worth the while of me doing these videos. That sounds very rude and I don't mean it to be. It's just some days I sit in here and I go, why am I doing this? A very small person trying to do a very big job. No, very small person trying to do a big job. It got all wrong way. But anyway, it'd be great if you could actually sign up and subscribe. What are we doing? Equations for straight lines. Yes, I know you've done this since goodness knows when, and I'm so sorry that it's doing this, but what are you going to actually learn? Well, yes, we're going to look at gradient intercept form. You're going to look at intercept form, and there's another one now. There's one called the point gradient form. And actually, I have to say the point gradient form, the reason it's in bold is because I love it, and it's being highlighted up there with regards to the learning. And obviously know how to find the equation of line given certain conditions. Now, the thing about Methods 1 and 2 is they actually throw curveballs all the time. Why? Because they're all worded questions. Previous years, you've been given questions, and all we've really done is just change the numbers. Now, we're not. Now, we're actually going to change questions. We're going to give you all sorts of information, which is information you're going to need, but in ways that will confuse you. And I'm really sorry. Don't blame me. Blame Barry. If you don't know who Barry is, you're very, very lucky, but he's a nutter. He actually has tried to make maths more complicated, and I'm going to try and make it simpler for you. Now, obviously, I keep saying that Methods 1 and 2 is really hard, and I promise you it does really get harder, or it gets more algebra intensive. But I also keep saying if your algebra skills are good, then you'll actually be able to cope with this. So that's fine. So let's get this done and dusted. I promise you, it does get harder. It does get harder, and it gets a lot more exciting, a lot more enjoyable as well. But anyway, gradient intercept form. Did you know it was called the gradient intercept form? I didn't until, well, yeah, actually I did, because I'm a maths teacher. So y is equal to mx plus c. Why on earth is called the gradient intercept form? Because the question or the equation has the gradient and the intercept, those wonderful letters m and c, which we have no idea why m stands for gradient, but it does. And there is a previous video highlighting above me now, which you can watch, and will show you the very much excitement of finding gradients of lines. Now, obviously, if I have the line here, y is equal to 3x plus 6, then automatically I know there that I have a line with a gradient of 3, and that's a gradient of plus 3, so it's a positively sloping line, and it has an y-axis intercept of 6. So using that information, I could sketch my graph, and I could say, it crosses through at 6, and it has a gradient of 3. What does that mean? For every 3 up, it goes 1 across. So I go 3 up and 1 across, I go 3 up and 1 across, and loeth and behold, I draw my line. Shonky once again, because it misses all those points, but if you were to draw that, you would obviously draw it more accurately. Likewise, if I have a graph and it shows me on that graph the intercept, and I can work out my gradient by doing rise over run, then I can express that line in y equals mx plus c form. Gradient intercept, fabulous. Then we move on to intercept form. Now, again, this is just a review pretty much of what we're going to lead into, but we've met intercept form in so many different ways. But one of the ones that we absolutely love is simultaneous equations. Yes, those elimination, substitution, CAS, matrix, graphical things are actually written in written in intercept form. Now, why do we love intercept form? Because I certainly do. Because it actually makes drawing graphs a lot easier, or drawing lines much easier. So we got the function 3x plus 6y equals 9. And the third thing I know is that this is called the y-axis and this is called the x-axis. But I know the y-axis is also called the line x equals 0, because if you think about it, we can draw a vertical line that passes through every x value of 0. And here, that must be given by the line y equals 0. And we love 0 as a number. And we love 0 as a doggy who's currently under my desk, actually asleep. Bless his little heart. Although when I said 0, he looked up. Moving on. 0 is great because when we multiply something by 0, it disappears. So the first thing I'm going to do is say, well, what happens if I let x equal 0? Well, if I let x equal 0, that disappears. I get 6y is equal to 12, and so y is equal to 2. And lo and behold, I've just found a coordinate. I have a coordinate on that line, which is 0, 2. So there we go. So 0, 2. Thank you very much. What about the next thing? Well, I have y equals 0. We know that we like 0 as a number because it gets rid of things. So when I have 3x plus 6y is equal to 12, when y equals 0, that goes. So I have 3x is equal to 12, and so x is equal to 4. Yeah, very good. So now x equals 4 and y equals 0, just another coordinate. So that's 4, 0. Put a little kiss there at 4, and lo and behold, joining those together, we have another very wobbly but sort of straight line. Now, we can actually work out formulas of straight lines if they give us a graph. So if I imagine here that I have a straight line that does this, and it goes through the values of 6 and let's say 4, then this is my y-axis. This is my x-axis, and this is my formula that says, well, if you want to find an equation of a straight line and they give you the graph that just has the 2 intercepts on it, then this is what you do. Believe it or not, this value here, A, stands for the value it intercepts on that x-axis, and B is the value it intercepts on the y-axis. So I'm going to rewrite this as x on 4 plus y on 6 is equal to 1. So that's not the equation that we normally like. We like to get rid of those, and in the trusted way that I hate fractions, I'm going to get rid of that divide by 4 first. So I'm going to multiply absolutely everything by 4. So x plus 4y on 6 is equal to 4, and now get rid of that divide by 6 by multiplying everything by 6. It gives me 6x plus 4y is in fact equal to 6, 12, 18, and 24. And there we go. There is my intercept form of my graph. So if we go back, did that work here? Well, what we notice is that the formula to be able to get me have those x-axis and y-axis intercepts is to end up so that it's x over a plus y over b is equal to 1. Okay, so scrolling over, I had 3x plus 6y is equal to 12. Well, if I'm trying to get this value here to be 1, I've got to divide everything by 12. So 3x on 12 plus 6y on 12 is equal to 1. Do a bit of cancelling down, gives me x on 4 plus y on 2 is equal to 1. And once again, I didn't even have to do that other way. If I could have done this straight away, I know, well, hold on a moment, that x is going to cross at 4, my y is going to cross at 2, and yep, it's all good. All right, see how this is? It's just great. Love, 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 love. So that's why we love the intercept form. Now, very important to know that there are special lines, and maths throws in tricks with these all of the time. Yeah, so just be very, very careful that when you're asked to find equations of a straight line, to see whether you can work out whether it's a horizontal or vertical line. So horizontal lines, lots of people go, oh, I know that. That would be x is equal to 3. And I go, no, I know it's a horizontal line and the x-axis is horizontal. But what it is actually the line here. He says, drawing that out, y is equal to 3. Now, the reason it's y equals 3 is because all of the coordinates on this point, on this line, all share the same thing, and that's that the y value is 3. How do I remember this? Well, it crosses through the 3 value on the y-axis. Yes, so because it's a horizontal line that crosses through the 3 on the y-axis, it's y equals 3. And so vertical lines, I hope you can realize. Again, what would we notice here? Well, it's crossing through the x value of -1, and so that actually has a formula or an equation of x is equal to -1. But likewise, if we looked at all of the points on this line, what do we know? The x value is equal to -1. So again, these are important lines to remember. Likewise, also important to know y equals x and y equals -x. More on those some of the time. And then my personal favorite is this one here. It's called the point gradient form. Now the point gradient form is given by y minus y1 equals mx minus x1. Now when on earth would we use this? And more importantly, does it look familiar to you? Well, actually it's just a rearrangement of m equals y2 minus y1 over x2 minus x1. But actually in this situation, we're saying, particularly with this equation here, that we don't know 2 coordinate values. We only know 1 coordinate value. Or more importantly, we only need to know 1 coordinate value. So if I had m is equal to y minus y1 over x minus x1 and rearrange it, then I get y minus y1 is equal to mx minus x1. So that's where it comes from. And again, I'm just going to reiterate, this equation is awesome because the only thing you need to know to be able to get an equation from the straight line, get an equation of a straight line from this equation is one gradient and one coordinate. Now the question might give you 17 coordinates, doesn't matter, I only need one gradient and one coordinate. So this question has been taken from the Cambridge Essentials textbook series, which is freaking awesome and something I use. And thank you very much to Cambridge for giving me permission for using their questions, greatly appreciated. So find the equation of the line which passes through the point. So they give me a point, minus 1, 3, and a gradient of 4. Thank you very much. So I'm going to use y minus y1 equals mx minus x1. So what do I know? I know my gradient, so that's going to go there. I don't know what x is because I don't need to. I only need to know one coordinate value, and that coordinate value gives me the values of x1 and y1. So x1, looking at this, is -1, so I'm going to put the -1 in there with a bracket, and then y minus 3. Now, believe it or not, what most people do is they make a silly mistake because they put -1 here. Because it's the first thing in the formula you fill in, lots of people put the first thing in the coordinate in, and I'm really sorry, but that unfortunately leads to a calculation error. So simplifying this gives me y minus 3 is equal to 4x plus 1, minus and a minus makes a plus, multiply out the brackets, but let's leave this the same, it gives me 4x plus 4, and then I'm going to add 3 to both sides to give me y is equal to 4x and plus 7. And there we go. I love that formula. It works so often. Well, it works brilliantly. And lots of people go, no, can't I do y equals mx plus c and I'll work out the c, and then if you want to, knock yourself out, but it's nuts. What about this one here? Find the equation of the straight line passing through those 2 points. Well, going back, I've got y minus y1 equals mx minus x1. Well, in this situation here, I know an x1 and a y1 because they've actually given me 2 coordinates I can choose from. But what I don't know is my gradient. So how do I find my gradient? Oh, it's too complicated. Rise over run, absolutely. So I've got 1 and minus 2. I've got 3 and 2. So there's my x1, y1. There's my x2, y2. And I know that my gradient is given to y2 minus y1 over x2 minus x1. So y2 is 2 minus 2. Oh, good. x2 is 3 minus 1. So 2 minus minus 2 is 4 over 2, which gives me a gradient of 2. So I've got my gradient of 2. Yes, it's an additional calculation I've got to do, but I'd rather do that than that y equals mx plus c stuff. So now I know my gradient is 2. Put that in there. I've got x, and I need to choose a coordinate value. Well, again, I don't mind which coordinate value I choose because they're both on the same line. Both of them are equally valid. I'm going to use this one here. And so what do I know? I know my x1 is equal to 3, and I know that y minus y1 is 2. So y minus 2 is 2x minus 6, and add 2 to both sides, it gives me 2x minus 4. This stuff is, again, relatively simplistic, and that's all you're going to be doing for this particular exercise, is just practicing that. But again, I promise you they are going to give you questions in a worded way that will try and confuse and trick. You have to see past the tricks, and the more practice you do, I promise you, the better you'll get. Now finally, the general form of the equation of a straight line, you thought it was y is equal to mx plus c. That is the equation of a straight line, but the general form is written like this: mx plus ny plus p equals 0. And you're going to say, whoa, how? Well, we know that we have y equals 3x plus 2. There is my equation of a straight line, which we can write in intercept form as 3x minus y is equal to -2. So just moving things around there, exactly the same equation. This one here is written in gradient intercept form. This one here is in intercept form. And if I just move that -2 over, I get 3x minus y plus 2 equals 0, which just so happens to be very similar to mx plus ny plus p is equal to 0. Now, I have to say, this here is a common trick that they use in exams. They'll write that down and they'll go, because it'll probably confuse about 40% of the state, if not, a significant proportion of the world, because it doesn't look like a straight line. And deliberately, when someone puts equal to 0, everyone goes, oh, I've got to solve it. It's a quadratic, because we knew that. We got told that by put it equal to 0, I solve it. And that's part of the problem. for me, whenever I look at an equation, I'm looking for powers of x's and powers of y's. Now, in this situation, I've got an equation with an x and a y in it, and my brain goes, if it's got an x and a y in it, it is a straight line. No two ways about it. Move it around, make it look the way I want it to look, and life is easy. Well, ladies and gentlemen, that was the equation of a straight line. Yes, I know it wasn't particularly difficult, but there is context now behind it, and there is the point gradient form that you know as well. My advice, use it. It's really good to see you. Thank you so much for taking the time in stopping by. If you haven't already done so, there is an opportunity to subscribe. Come on, you know you want to. And can you do me a favor? Tell your mates to subscribe as well. Otherwise, there's a video loading over there of similar maths fun. Have a good day. MaffsGuru signing off.